Well, we have seen the basic way the price ratios and of beaver and deer were determined. Now we will introduce tools to the system. We assume, I mean, the hunt of the beaver needs a spear, and spear production of spear needs also 10 hours, but spear can be used for 10 hunts. So that means the production of the per hunt time that is spent for spear is 2 hours. Let me make it more clear. To hunt one deer, the tribe 2 needs to spend 10 hours now, plus they need to spend two additional hours per deer they hunt to get a spear. You might also think it that way. I mean, when you hunt with the spear, you can hunt 5 deers. So, in general, to hunt the deers themselves, you need 50 hours. To produce spear, you need 10 hours. So in total, you need 60 hours. Since this 60 hours is needed to hunt 5 deers, in total, you need 12 hours. So now, to hunt one deer, you need 12 hours. So the price ratios should be 12 to 2, which is 6. So if one beaver is $1, one beaver is $1, then one deer will be $6. So still the ratios can be defined by the labor time necessary to produce the product plus the time you need to produce the tools you need to produce that product, or the inputs you need to produce that product. So now, what will happen if we introduce capital and basically capital and well, of course, this I should write $6 here and $1 here, since I mean the final values are final value of the time necessary is expressed here. So what will happen if we introduce labor and capital here? Let's assume we have labor and capital, and workers are paid $1 wage, and the profit is 20% of the cost. So for $1 spent, a person should get $0.2 profit. So in this case, for the beaver, wage is $2. Profit is $0.4. Price is sum of them, $2.4. And for the beaver, wage is $12. Profit is, I mean, this is $1 per hour, by the way. So wage is defined per time work, so I should write per hour. So it's $2 because you have the workers have worked 2 hours to hunt the beaver, or a worker need to work for 2 hours. Profit is $2.4, and price is $14.4. the sum. So this is 6. Let's find whether we will find the same value when we divide 14.4. So is it 14,4 divided by 2 over 4? Yes, they are same. So when we introduce capital and labor, we still have the same number. Well, there are two cases when this number will change. One case is when sphere is, in the second case, of course, we had, instead of tribes, now we had companies. And company, since now we have workers and capital. Well, one case when things will change is when we have, instead of the sphere produced by the company 2, instead we have a company 3 that is producing the sphere. Let's now write this case. Everything else will be the same, but the calculations here will change. So sphere is still produced in 10 hours and used for 10 hunts. Not 10 hunts, actually, this should be 5 hunts. I'm sorry. That was a major mistake, but you can, I believe, guess it. So 5 hunts. So still same. These two things are the same. In this case, basically, this will of course disappear. This will of course not anymore true. The time necessary to hunt the deer is still 12 hours when we take into account time spent to produce spear also into account. But now for spear, the workers are getting $2. It's just like the beaver case per deer hunted. And the profit is $0.4, and $0.4 is the price. So this is wage, profit, and price. So wage is, in this case, the company is just hiring the workers who are hunting the deer in this case. So they are paying to $10 in this case. So the price of spear per hunt is $2.4. If you want, you can also calculate, make the same calculation for, total cost of spear. Total cost of spear is actually $10, since it's used, total wage you pay for the spear is $10, since it is produced in 10 hours. The total profit is $12, so the price is $12. And if you divide this to 5, then you find 2.4, basically. So the company pays $12 for spear, but it uses this per hunt. So the price of spear per deer hunt is $2.4. So basically, the cost is $12.4, and the profit is the cost 12.4 times 0.4 dollars. So the price is, you should also add the price of deer is basically 16. Now this amount plus 12.44. So the ratios now become this amount divided by 2.4 not anymore 6. It's not anymore 6. Is deviation? Let me see the deviation. Although this is a hypothetical thing, I mean, how much in reality the ratio of the cost of the things that are bought from other companies is to the ratio to the things that are actually produced in that company, that's another thing. This 20%, I mean, in this case, this is larger than what Ricardo has foreseen, but in reality, actually, the ratio of the cost, the price of the inputs or the tools that are bought might be less than the wages paid for the workers. That is according to Ricardo's observation. So this is one case. The other case is the rent. And according to Ricardo, rent is actually regulated by a different dynamic compared with the way the wages are regulated. So even though in general the equilibrium prices can be estimated by looking to the labor time spent for producing that product plus the time needed to produce the inputs and the tools necessary. When you calculate rent, basically, when rent is also part of the cost, then that cost is actually calculated in a different way. In order to explain it, the Ricardo defines different fields with different qualities. I think 3 fields are enough. So field 1, field 2, field 3. It can be expressed in a different way, but for now I will express basically how much, the fields have different fertilities, but you may still produce same amount of product by doing more work on those fields. Alternatively, with the same amount of labor that is spent, the fields might give different amount of yields. In both ways, Ricardo's theory of rent can be seen, but it would be easier if we just calculate the labor needed for producing, for example, 10,000 or 10,000 or 1,000 tons of grain, for example. So, case 1, case 2, case 3. We have 3 cases. In first case, labor needed. First, let me do that. So let's say the field 1 is very fertile, so you only need 10,000 labor hour. Labor 2 is less fertile, so you need 25,000 labor hours. And labor field 3 is very much less fertile, so you need 100,000 labor hours, for example. So, how much rent we get if only field 1 is in use? So, if only field 1 is in use, so not in use. So, if demand of food is very low, so only the most fertile land is in use, we might assume that part of the most fertile land is not used at all. So in that case, I mean, since there is not very high demand for the most fertile field, even the rent people get from the field 1 is 0, since I mean already out of the much of the field 1. The first type of the most fertile type of fields are empty anyway. In case 2, demand for food has increased, so all of the areas that are at category field 1 are in use. In addition, some of the fields that are field 2 category are also in use. So we will continue.